at the moment, the only force acting on our coffee beans is gravity, which is boring. It's no good. What we need is a force going in this direction from here and in this direction from here. And what we can do is put information onto the geometry before it is simulated, and that will be understood by the DOP sim. Okay, so we can put information onto the points, which will be copied onto the geometry, such as velocity, and then transfer that onto the packed geometry that will be taken into the DOP network. And this is a common way of setting up some kind of a source, okay, source velocity. So for this kind of direction, we're going to use a normal, right? So if I put a normal node and change it to points, visualize that, we've got these vectors pointing in this direction. So we'll do the same thing for the other side. Give that normals as well. These will transfer onto the scattered points also, which is handy. And to make this more interesting, they're all the same at the moment. We will use what's called a point VOP, and this we will, I believe we can put it down here. Okay, so a point VOP is another sub-network. We'll dive in there, and VOP stands for vector operators. Oh, sorry, not vector, vex operators. So it's kind of a visual vex system. Okay, and it's very common for people to use this for noise. So giving noise to change surfaces, to colors, you know, often with emitters, if you're emitting particles or fluids, it's very common to use one of these. So inside we can see we've got, the way this works, we go from left to right. Here we've got our inputs, things coming in to the geometry. These are all the kind of defaults. They're not all of these are on the geometry. In our case, we've got a position and a normal, and that's a point number as well. Primitive numbers, we got some of them as well, but we don't need that. And then we use that information, perform some actions on them, and then output the results back to here, or we can output it into other we can output other attributes also, but today we're just going to be creating a velocity. So to use that, we'll use the position and the normal of the points that we have. We should have both. I don't know why we only see one. Let's take a look. There we go. Okay, so we want to make this a bit more interesting. At the moment, they're all the same. What we could do is just connect the normal to the velocity. And now, if we go here, in your case, you might not have this. So if you go to come out, turn off your normal visualizer, information here, and then here you can see V for velocity on your points. If you just click that, and it will create a visualizer for you, which is here, and you can turn it off and on there. So to make these more interesting, we'll use a turbulent noise, and for the turbulent noise to work, we need a position. Okay, and we will be creating we'll be using this to create a noise, and the way that this works, we're going to multiply the values. So we're going to create noise here, and multiplied with the normal, with the vector that we already have. Okay, so connect that in there, noise underneath. Maybe to visualize it, we can for the moment connect it to the color, and that should give us something. As you can see, we've got yellow and green for the moment, which is not perfect. Let's try increasing the frequency. Let's see. Let's do tenfold. Not bad. Maybe a little more. It's kind of hard to see, but you can see some changes in the colors there. Maybe if I connect this to the velocity, there we go. So now you can see we've got a weaker velocity there and a stronger velocity here. Okay, well, we can play with the frequency, the amplitude for the overall strength. Let's give it some more, maybe 2. No, let's see how that works out for now. Go back. Okay, so we got velocity coming in here. Got our rotation, all this is the same. Our velocity should be getting copied over here. There. So it's been added. It's being added to 0, so it's basically setting the velocity. So if we come down here, there we can see the velocity on every single point. And then in the assemble, it disappears. So we need to transfer the velocity. Normally, in this case, again, it's not really necessary. You need to transfer the name as well. These will be transferred onto the points where you need to store attributes which you will use in a rigid body simulation. Groups as well. I'm going to transfer 1, 2, 3. I want all of them. Instead of writing or clicking these, very typical easy thing to do is to press star. The star means everything available, transfer them. So any group will be transferred onto the points. I want to use this later for applying the textures. Okay, so let's another thing we're going to do is just delete these colors now. We don't need them. They will disappear. All right, dive back into the DOP network. If you can't see, by the way, if this is like that, if you press space and H, it will home everything. The same here. Let's say if you're lost, it's easy to do. Press space bar and H, or space and F, and I will home the view, and you can find your way. And if we go into we need to import the velocity. So in your Abidi packed object, if you go to not the initial state and this little checkbox, inherit velocity from point velocity. So we've got velocity on our points. Take that, and there we go. We can see it already. So this will be an initial velocity. We'll give it an initial kind of kick for the first frame, and then it will go. I also want to drop the gravity. So this is what real world gravity is, but I'm going to change it, just put it down to 1 for now, something like that. What else? Well, let's see what we get with that. Well, as we're simulating now, or maybe before now, we should be saving as much as we can. So you can either just go to File, Save, or what I typically do is just Control S now and then. If you're feeling nervous about what you're simulating, if you've got really heavy simulations or textures or something that's difficult for your computer to do, I highly recommend saving as you go on. Houdini can crash. it does happen. So sometimes when Houdini crashes, before it closes, it manages to save a temporary file, and you can open that. If Houdini crashes, it'll give you a message and say that a temp file has been created. To find it, the easiest way is to go to File, Open, Temp, and you can find them here. Okay, so let's see what that gets us. Press play. Let's see if my Houdini crashes. Hopefully not. There we go. So got something different. A bit of movements. Still too much gravity, I think. So I'm just gonna put that down to 0.1. Let's try that. There we go. It's getting there. Okay. Still, I'd say we need more velocity. So let's go back here and one thing we could do is add a fit node here. Drop that in. Okay. So here, similar to what we did earlier in the expression, we take in values from 0 to 1, and we can fit them. We can reorganize these this attribute. So I don't want anything with a velocity of 0, so I'll raise the minimum to 0.5, let's say. So there we've got quite a bit more velocity on that. All right, so let's see. Again, Control S, save that before we start. And let's see what that gets us. There we go, much better now. So there you can see they're not all flying at the same speed. We got some variation. We can work on that to get it, you know, we have artistic control. We can make some fly even faster, some slower. But you know, the principle is there. It's working so far.